Hello, the purpose of this video is to share two examples of how completing the square can help us find zeros for quadratic functions, which is equivalent to solving quadratic equations. So we're going to begin with one example like this. F of x equals x squared plus 6x plus 3. And of course, this is connected to completing the square. And we can see that to complete the square, I would arrive at this form because I do x and half of this middle term square, x plus 3 square. That means somewhere I would have a 9 in my bottom term, and then I have 9, but my function only has 3, so I need to subtract 6. So I have completed the square here, and that takes me to vertex form. Now, here's the key idea. We need to remember that when we find the x-intercept or zeros, the function value is 0. And that is all we have to remember, because that means that if we evaluate or we put this function at 0 and we identify the value for x, or the values for x in this case, we would have found the x-intercepts. So all we have to do is write this as an equation. X plus 3 squared minus 6 equals 0, and that is going to produce our intercepts. So going back to our algebra, we can solve this equation by principles that we learned before. So in this case, the first step would be add 6 to both sides, which produces the next step, x plus 3 squared equals 6. And then the next step here would be to take the square root from both sides, which would produce this outcome. I want you to notice something. On the left side, the square root of something squared are opposite operations. So x plus 3 squared, and then if we do the square root of that, we end up with just x plus 3, which is exactly what we want. But just as importantly, on the right side, notice that now we have the square root of 6, and is positive or negative. And that is because when we do the square root of a positive number, there are two possible values that can meet it. Any number squared is positive. So there will be a positive root and a negative root for any number that has that is a positive. So that's why we write plus and minus square root of 6. Then we're going to continue with our final step, which is subtract 3 from the left side, and these would produce these as our last step. Negative 3 plus or minus the square root of 6. Notice that I just organize it a bit differently. If you did plus or minus the square root of 6 minus 3, it'd be just the same. And we're just going to make a little memo here that the square root of 6 is approximately 2.45. So now we're ready to find our two values for our intercepts or zeros. The first one, we're just going to take the positive root. So it's going to be negative 3 plus approximately 2.45, which is approximately negative 0.55. Of course, we could have left the root like that. In this case, we wanted to calculate it approximately. And the second root is going to be negative 3 minus the square root of 6. And in this case, is approximately negative 5.4. And that means, roughly, if we sketch our quadratic, that this is what it might look like. We would notice that we have our vertex that we found very early at negative 3, negative 6. And these two intercepts would be one at negative 5.4 approximately, the other one at negative 0.55. Good. Now, second example, these might go a little quicker. So we have the same idea. We have a quadratic. This, in this case, looks a bit different. And we, same thing, we're going to find the zeros. This time, this is what the completion of the square looks like. And by now, we're going to leave that for you to verify. And then that means now to find the zeros, I'm going to make the right side of this equation equal 0, because that's where the intercepts are, and just do algebra to isolate the x on the left side. So I would add 29, which gives me x minus 6 squared equals 29. then I would do the square root on both sides. And I'm actually showing it this time, the square root of x minus 6 squared, and again, the positive or negative square root of 29. And that is equivalent to this. And finally, our last step is to add 6 on both sides, and we have 6 plus or minus the square root of 29. And similarly to our previous example, square root of 29 is approximately 5.4. Again, I could have left 6 plus root 29 and 6 minus root 29 as the answers, and that would have been fine. But in this case, we just wanted to put the approximate value to sketch the graph. And that means our first x would be 6 plus the positive side, 5.4, which is 11.4. And the second root would be 6 minus 5.4, which is 0.6. And that produces a graph that looks like this. We have the vertex at 6 and negative 29 that we find from completing the square, and the two intercepts that we just identify at 0.6 and 1.14. The benefit of doing a little sketch like this is that it allows us to verify that our calculations were accurate and that we didn't make any calculation mistakes because the graph is consistent. The um, axis of symmetry is between the two intercepts, and the parabola opens the way we thought. Just as a last note, this is equivalent to solving this equation, x minus 12, x squared minus 12x plus 7 equals 0. So just keep in mind that every time we're finding zeros, we are concurrently solving quadratic equations of this form. I hope this was useful. Thank you.